Okay, hi guys. This is going to be the spring semester final review. It's very long, so let's try to get through this real quick. You have any questions, of course, you can ask me in class, message me on Canvas, or send me an email, or whatever. Okay, anyway, so first one, number one. Are the triangles similar? How do you know? And this one is a yes because of angle similarity. That's what angle with that little squiggle means. That squiggle, by the way, is called a tilde. That's the symbol tilde. Anyway, but it means congruent in geometry. Anyway, you know that because this angle M, you see on the outside, well, that is the same one on the inside there. Like here, let me point right here. These are interior. These are they're right opposite. These are opposite angles, so those are the same. Anyway, if these are the same, then that means that this angle right here and this angle, you have two angles in here. You have the same thing over here, 39, and this angle right here. Those are also opposite angles, so those are the same. So because you have these two triangles that are similar, that are the same, that's how you know that these are similar triangles. Okay. Anyway, number two. So here, what is the value of A and B? Okay, well, first of all, you have A right here. This is like the height, okay? Really, you're supposed to do this using the geometric mean, but you're supposed to be able to say 4 over A equals A over 16, just like I have set right here. But it's just easier to just square that height. A squared equals, and then just multiply these two lengths together. 4 times 16 is 64. From there, you can get the square root of both sides. A equals 8. Okay, so that's the first part of this. Now you need B. So now we know that that's 8. This is 4. What we can do is use the Pythagorean theorem here. So I'm going to say A squared plus, I'm going to call this side my big B. I did these in capitals to avoid confusion. So the A is 8. The big B is 4. I'm looking for the hypotenuse B. Little b right there. So 16 plus 64 is 80. Square root of that is you can simplify this down because 80 is like saying 16 times, let me write that in here. That's like saying 16 times 5. So if you get the square root of both sides, the square root of 16 is 4, and then the square root of 5 is square root of 5. Okay, let's try to go a little faster here. So, okay, so what is the value of x? So the way you got to look at this here, these are similar. You have this big triangle, and then you have a mini up here. So you can say, first of all, let's look at the mini. 7 is to x, and then it's going to be the same thing for the big one, but for this one, you're going to have to add these together. 35 and 7 is to this side over here, which is x plus 40. 7 plus 35 is 42. Let's cross multiply. Here's 7 times this whole thing. That x plus 40, so that's in parentheses. X times 42 is 42x. You need to get the x's on the same side, so let's subtract 42 both sides, subtract 280 on both sides, divided by negative 35. You're going to wind up with x equals 8. Okay, number 4. Find the length of the leg. Okay, first of all, this is a 45, 45, 90 triangle. So, in a 45, 45, 90, I'm using the A as, sometimes you've seen this like with another variable, but these two sides are the same. The hypotenuse is one of these legs times the square root of 2. Well, I know what this is. This is 24. So I'm going to use this to solve for my A. Okay? So I'm going to say that the 24 is 8 times square root of 2, divide both sides by the square root of 2. Okay, so that's what A is, but I have to rationalize this because I cannot divide by the square root of 2. So let's just multiply on top and bottom by the square root of 2. I'm going to get 24 square root of 2. Square root of 2 times square root of 2 is just 2 because 2 times 2 is 4. Square root of 4 is 2. 24 divided by 2 is 12, so this is 12 square root of 2. Okay, number 5. Find the value of the variables. Okay, so your variables here are x and y. So this is here you have a 30, 60, 90 triangle. You know that because that's 30, that's 60, so this 30, that's 90, so this has to be 60. And a 30, 60, 90, whatever the hypotenuse is, the side adjacent to my 60 is half of that. or vice versa. So since we're given this 11, that's why I know this is 22. This is the key thing when you have a 30, 60, 90. Whatever this is, then the height right here, or this side adjacent to the 30, has to be this, in this case, 11 times the square root of 3. And that's all I wanted here. So our x is going to be 11 square root of 3, and my y is just going to be 22, which is twice the 11. Okay, number 6. Viola drives 2 kilometers up a hill. That makes an angle of 9 degrees with the horizontal to the nearest tenth of a kilometer. What is the horizontal distance that she travels? First of all, 9 degrees is very, very small. Okay, this is making it look much bigger than it really is, but just so you can see that. Okay, so in other words, you're going to go up the hill 2 kilometers. This is just 9 degrees. I'm being basically asked what is x here. Okay, I put the y in here just to, in other words, this is x, that's horizontal, my y is vertical, whatever. But the y is unimportant here. Okay, anyway, I'm just looking for this here. Well, I have this angle and I have the hypotenuse, so I'm going to use cosine. Remember, this is trig. So I need the adjacent divided by my hypotenuse. So adjacent over hypotenuse, which is cosine. Well, that means that I'm going to have my adjacent is going to be the x. So that's going to be x. Remember, adjacent just means right next to. Anyway, so there's going to be x over the hypotenuse, which is 2. And this is going to be equal to the cosine of 9 degrees. I'm just going to put this over 1 and cross multiply. Remember here, when you have a trig function of an angle, this is just some number. Cosine of 9 degrees is just some number. When I cross multiply, I'm just going to say 1 times x is just x. And 2 times cosine 9 is just 2 cosine 9, which is just going to give us a number. And this is going to round to 2 kilometers. They specifically asked here to the nearest tenth. To the nearest tenth of a kilometer. Okay. Anyway, so number 7. Okay, find the value of w and x. Okay, so first of all, here, this is 50, this is 90, so this has to be 40. And if this is 90 here, this has to be 90 on the other side as well. Okay. Well, if this is 40, this has to be 50. That's a 5. That almost looks like an 8, but that's a 5. Okay, that's 50. So this one is 40. So I know my x is 40. I just need my w right here. So the way that I'm going to do that is I'm going to use more trig. So I'm given this angle right here. I want this side right here, which is opposite my 50. So I'm going to say my side opposite, and I have my hypotenuse here, so I'm using sine. So the sine of 50 degrees is going to be the side opposite, which is w, over the hypotenuse, which is 10. Let's just put this over 1 and cross multiply. Okay, w times 1 is just w. 10 times sine 50 is just some number. And when you do that, just messed up right there. 10 sine 50 is just going to be 7.66, blah, 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 blah. They specifically asked for here, this to the nearest degree. So let's just round up. This is just 7.7, which is in the back. Which is funny because it specifically says the nearest degree, but then my answer in the back is with a decimal. Okay, so number 8. Okay, that took 9 minutes, so let's kind of try to speed this up. Okay, what is your description of 2? Well, what is angle 2? Angle 2 here is your angle of elevation. If you're at your horizontal and you look up, this is elevation. If from here, if you look down, like in angle 3, that would be your angle of depression. Anyway, so your answer here is just angle of elevation. When I first looked at this, I thought it was asking for us to find it. You don't have any information to do that, so don't worry about that. You just have to be able to say that that's your angle of elevation. Okay, number 9. Okay, approach the runway, blah, 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 blah. Okay, so this is 10. Okay, this makes a 90-degree angle here. Okay, so this is 90 degrees right here, and this is 10. This has to be 80 right here. Okay, so I know what this side is right here. This is, first of all, I have my hypotenuse here, that's x. So I'm going to have to use something else. I don't have the horizontal here, so I'm going to have to use this side adjacent right here, which is going to be 1983. So I'm going to say the cosine of 80, which is adjacent over hypotenuse, is going to be this side right here, which is going to be 1983. I'm going to divide that by my hypotenuse x. Remember, x is what I'm looking for. I'm just going to put that cosine 80, which is just some number, over 1 and cross multiply. X times cosine 80 equals 1983. Divide by cosine 90. Remember, I'm just saying a number divided by a number. And that should be that. But they're trying to trick you here too, because they gave you this in feet. But they're asking for this in miles. Like how many miles is the runway? So easy fix. This is in feet, so we're just going to convert this. In 1 mile, there's 5,280 feet. So when you do that, the feet cancel. So now this is in miles. So I'm going to have 1983 over cosine of 80 times 5280. Do this in your calculator. You're going to get 2.6, blah, 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 blah. Rounded to the nearest tenth. This is just going to be 2.2 miles. Okay, number 10. We're asking for the midpoint. Okay, for the midpoint, we're just going to use the formula. This is actually pretty easy. We just need to get the points. Well, this point right here, P, this is at -4, 6, and Q is at 8, -6. So remember, your midpoint is an actual point. You're just adding your x's together. So -4 plus 8 over 2, and you're finding the average. -4 plus 8 over 2. And then let's add the y's together. 6 plus -6, which is 0. And that's over 2. That's a 0. That almost looks like a 6, but that's a 0. That's terrible. I made that look like an 8. That's a 0. Anyway, 4 over 2 is just 2. And 0 over 2 is just 0. Okay, anyway, so our midpoint right there is 2, 0. Okay, so let's look at number 11. Okay, what is the midpoint? Well, the midpoint here, well, let's look at what we're being asked. We're saying the midpoint of CF is, or we're saying M is the midpoint, and we're given these points between C and F. So for illustrative purposes, there's C, there's F. We're being asked for the point that's in between. I'll be honest, when I first was drawing this, I thought it was going to be a little bigger. This actually came out really small. I'm looking for the point that's in the middle. Once I find that midpoint, now I'm being asked, well, between the midpoint and F, what is that distance? Okay, that's what they're asking you here. Okay, so first of all, let's find the midpoint between these 2 points right here. So I'm just going to, the points that they're being given. So I'm just going to add the x's together, divided by 2. 3 plus 5 is 8. 8 divided by 2 is going to be 4. And then my y's are 7 and 5. Add those together, that's 12 over 2 is 6. So this is my midpoint. So that's how you got to look at this. This is my midpoint right here. The question is, how far is it from this M to this F? So this M is somewhere between these. Okay, so we're just going to find the distance between M, which I have, and between F, which is 5, 5. So we're using the distance formula. Distance formula, you're just saying the difference in the x's. So if you see this, it's like x2 minus x1 quantity squared, but the order doesn't really matter. So I'm doing x1 minus x2 quantity squared. It doesn't matter because you're squaring it. Okay, and then plus the same thing with the y's. I'm just saying y1 minus y2 quantity squared. So I'm saying 4 minus 5 is -1 squared, which is 1. It should have been -1 squared. But either way, that's going to be 1. And then 6 minus 5 is 1. -1 squared is 1. 1 squared is 1. 1 plus 1 is just 2, so that's square root of 2. Okay, a whole lot of effort just to explain something that's, not that hard to find. Anyway, number 12. What is the measure of one of the angles of a regular 30-gon, which means a 30-sided polygon? So we're going to have to remember the formula n minus 2 times 180, which tells us what is one of the angles of a regular polygon. So I'm saying n minus 2 times 180. Our n here is 30. You know that because it's a 30 gone. 30 minus 2 is 28. 28 times 180 is going to be 5,040. Now the question is, so that's the sum of the interior angles if you add all of them up inside that 30 gone. Okay, the question though is, what is just one of those angles? Well, if you just want one of them, you just got to divide by the number of sides. So I'm going to take this 5040, divide that by 30. That's just going to give us 168. Okay, number 13. What is the value of x? Okay, so I'm looking for this right here. You have 1, 2, 3, 4, 5 sides in here. I need to find out what are these all equal to. First of all, I'm going to add them all up, but what is this equal to? Remember that n minus 2 times 180. I need to do this because I need to see, well, what do all of these supposed to add up to? So 5 minus 2 times 180, I'm saying 3 times 180 is 540. So I'm just going to add all these up in here. 148 plus x, 3x plus 10 plus x plus 112, and then plus the 90, of course. And I know this is going to equal to 540. Okay, so once I have that, I just have an algebra problem here. Just combine your like terms. 3x plus x is 4x. 148 plus 10 plus 112 plus 90 is going to be 360. Subtract that from 540. So I'm going to have 4x equals 180 divided by 4. You're just going to get x equals 45. Okay, number 14. Find the values of the variables in the parallelogram. Okay, so this is the way you got to look at it. First of all, this 31 and this x, those are going to be the exact same thing. You know that because these are alternate interior angles, which y in this one would be 2, but you don't know what this is. So all I can say is that x is 31. Okay, now, remember in a when you have a parallelogram like so, the two angles that are side by side, that are which you would say that these are consecutive because they're one right after another, that these two are going to be supplementary, which means they add to 180. So I'm just going to say x plus y plus 196, plus 96 is equal to 180. Well, I know what x is now. Remember, x is 31. So I'm saying 31 plus y plus 96 equals 180. Subtract 96, or first of all, 31 plus 96 is 127. Take that away from 180. You're just going to get y equals 53. And then our last thing, well, what is z? Well, remember, z and 96 are opposite angles. These are the exact same thing. So z is 96. Okay. Number 15. What is the most precise name of the quadrilateral? Okay. Our choices are, this is four-sided. It could be a rhombus. It could be a rectangle. It could be a square. It could be a trapezoid. This is either a really terrible representation of the, like, terrible graph, but I graphed these. And the answer is that this is a parallelogram. I say that because to me that doesn't look like a parallelogram, but I don't have many choices here, so we're just going to go with that. Okay, so that is 15. And we have a few more pages to get through. Hopefully that was like another 9 minutes. Let's try to speed this up again. Okay, so in the rhombus right here, remember in a rhombus, all the sides are the same. All the sides are the same. Oh, and the other thing about a rhombus right here, all the angles where this intersects, these are 90-degree angles. Okay, so I know that 1 and 2 are both going to be 90 degrees. Well, they're telling us specifically here that like angle 1 is 15x. So I know that 15x equals 90. This is angle 1. This almost looks like a 4. I'm trying to say angle 1. Okay. So anyway, if you solve for x there, you're going to get 6 degrees. Okay, let's look at angle 2. Angle 2 I know is going to be 90 degrees. Well, angle 2 is x plus y. So I'm saying x plus y equals 90. I know what x is now. I just solved for it. So that's 6 plus y equals 90. Subtract 6 from both sides. I get y equals 84. And then I have z. Z is 30x, or 30z. Say that again. And the measure of angle 3 is 30z. So I'm saying 30z is equal to 90 divided by 30. You're just going to get z equals 3. So that's pretty easy. Okay, number 17. Find the values of a and b. Okay, so these are consecutive, so these are going to be supplementary. So 109 plus b is going to be equal to 180. Likewise here, a plus 65 is also going to be supplementary. That's 180. So solve that for a, subtract 65 both sides, a equals 115. Over here, subtract 109 on both sides, b equals 71. Okay, number 18, find the values of the variables and the lengths of the sides of the kite. Okay, so first of all, I know that these two are the same because they have the same congruence markings. You see, like, that just has one slash there. That has one slash. In other words, these two are equal. These two have two slashes in here. So their congruence marking, I know that these are equal to each other. Okay, I already have the answer for that, but that's how I find it. First of all, I know that these are going to be equal, so I'm going to say y minus 3 equals x plus 2. Okay, now at this point, I can't do anything. Okay, I'm going to have to come over here and say, okay, 2x plus 2 equals x plus 11. And so here, there's only one variable. I can solve for that. Subtract x on both sides, you get x equals, subtract 2 both sides, x equals 9. Now I can come back over here and say, okay, so I have 9 plus 5, and 9 plus 5 is 14. So that's that. I found those variables, but now I need, well, what are the sides of these? So I just need to plug in the x over here. So 2 times x is 2 times 9 is 18, plus 2 is 20. Or even if you did that here, 9 plus 11, you're still going to get 20. Remember, these two are the same. Now that I have my y, I can say, oh, in fact, here I had my x too. I could just plug that in here and say 9 plus 2 is 11, or if I put the y in here, 14 minus 3 will get 11, so it's the same right there. Anyway, number 19. So we have this triangle right here. It wants to know, well, what kind of triangle is it? Is it going to be scalene, isosceles, or equilateral? What's the difference? Scalene means none of the sides are the same. A isosceles means you have exactly two sides that are the same. And equilateral means they're all the same. Okay, so how are we going to find out? We need to get the distance between each of these points. So t to v, if I do that, my distance is the square root of 65 between t and the last one, s. I'm also going to get the square root of 65. I do between v and s, I'm going to end up with the square root of 52. Well, two of them are the same. Therefore, that has to be an isosceles. Again, scalene means that none of the sides are the same. Isosceles means exactly two are the same. Equilateral means they're all the same. Okay, so this would be isosceles. Okay, so number 20. Okay, what is the minor arcs of circle O? Okay, so first of all, our minor arcs means that the arcs here, the arc, like for the arc length or whatever, the arcs are less than 180 degrees. So I have this one up here, H to J. I have this one, J to K. I have this one, K to L or L to K, same difference. H to L. So those are your four minor arcs. Okay. 21, they're asking for major arcs. Remember, a major arc specifically have to be greater than 180. Okay. Now, when I was first doing this, I messed up because I said, okay, BCD, right? It's not just that this goes through 3 points. It's they have to be bigger than 180. And both of these that I had initially, BCD, that's less than 180. In fact, that would be exactly 180. So that is not major. And I also had CDA, that is also 180. That is not bigger than 180, therefore that doesn't count, so I put an X through there. Okay, if you want bigger than 180, we're talking about BCA, that's more than 180. DAB, actually, no, that's not gonna, it would have to be, okay, anyway, so there's that, and then ABD, AB, and then this one way over here, that would be major because that's bigger than 180. I just paused on that one because I'm like, wait a minute, DAB, that looks like exactly 180, but that's what was in the back, so we're just going to go with that. Okay, but like I said, measure specifically has to be bigger than 180. 22. Find the measure of angle, not angle, the arc of CDE. We're talking about C, D, and E over here. Okay, remember in a circle, these add up to 360. I have 1, 2, 3, and then 4 little sectors in here. Well, I have 3 of these, so I can solve for this last one. This last one here has to be 145 degrees. So now the question is, what is a measure of CDE? So that means I just need to add these angles in these 2 sectors. 145 is 27. It's just going to be 172. That's 172. It looks a little messy there. Okay. Okay, that's progress. So that page was only 7 minutes. Okay, find the length of arc of X up here, XPY, or YPX, same thing. Okay, and we want this in terms of pi. So we have to use this formula right here. First of all, they're giving us, we need an angle in here. I know that this is 90 because it has that little square there. I know that's 90, so the one on this other side, this whole thing here, which I need, is going to be 270. Okay, you can either say 360 minus the 90 for the 270 or whatever, right? Anyway, I'm using this formula. I'm saying m over 360 times pi r times 2 pi r. 2 pi r is circumference, and I'm just looking for the length of this. So in other words, a piece of the circumference. Anyway, so I'm saying 270 divided by the 360 times 2 pi times my radius. My radius of this circle right here is just 10. So you can say 270 over, you can just put this in the calculator and it's going to be with pi because they tell you the one in terms of pi. And if you do that, you're going to end up with 15. You could put it in 270 over 360 times 2 times 10, you'll just get 15. This is very ugly. Let me do this again. This is just going to be 15 pi. That looks a little neater. And this was meters. See? Quick fix, 15 pi. Okay, so there's that. Okay, number 24. They want find the area of the figure. Okay, so now we're talking about sector area. So the same way we just wanted for the arc length, we just found like a piece of this. So in other words, we have to multiply by the piece of the circumference. For arcs, for sector area, we need just a piece of the area. The area of a circle is pi r squared. So I just need this angle, divide that by 360. So 165 divided by 360 times pi times my radius right here is 7 squared. There's my radius. That's 7 squared. Anyway, if you do that, you're going to get 70 point blah, 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 blah. We want this specifically to the nearest tenth, which is 1 decimal place. So this is going to round to 70.6 meters squared. 25. Find the degree measure of this angle. So they're giving you the angle in radians. If you're converting from radians to degrees, you have to multiply by 180 over pi to put it in degrees. So when you do that, we're just multiplying this by 180 over pi. The pi's cancel. 10 goes into 180. Those zeros cancel. 7 times 18 is just going to be 126. Or you could have done this in a calculator, whichever one. But the pi's cancel. Okay, number 26. Find the radian measure of this angle. Of an angle that's 110 degrees. So here I'm going from degrees to radians. So I have to multiply by pi over 180. When you do that, the degrees on the bottom cancels degrees, so now this is in radians. So I have 110 over 180. You can cancel 0, so it's just going to be 11 pi over 18. 27. Write the standard equation of the circle. Here I'm given my center, which is my h and my k, and I'm given my r. So the standard form of an equation of a circle is h minus k quantity squared plus y minus k quantity squared equals r squared. So let's plug in the 10. Let's plug in the h, which is 10. So x minus 10 squared plus y minus negative 6. Remember, you subtract the negative, that becomes plus 6, and then equals 6 squared. 6 squared is 36. So x minus 10 is quantity squared plus y plus 6 quantity squared equals 36. Number 28. Find the area of the parallelogram. Oh no, they're giving you the area of parallelogram is 280 square centimeters, and the height is 35. What is the base? Whether it's a parallelogram, rectangle, remember a rectangle is a parallelogram, that area is just base times height. And here, I could have put the 280 on the other side, but I just put it on the right side since I'm solving for b. So I'm saying b times 35 equals 280 divided by 35. 280 over 35, that's just going to give you 8 centimeters. Okay. Number 29. Okay, find the area of a trapezoid. Okay, I put question mark on here because I'm not getting the answer that's in the back, but I did it 2 ways, so I think it's incorrect. Okay, so first of all, I did it using the formula, for because this is a trapezoid. The area of a trapezoid is 1/2 at the bases times the height. So here this is 18. Here this is a 30, 60, 90, which I thought was the point of why they were telling us that that's 60. Okay, so this is 60. Hold on. This is 60, and they give us the hypotenuse here. Remember, in the 30, 60, 90, the side adjacent to the 60 is half of the hypotenuse. So this is 8, so this is 4. And you needed this one because that's how I know that my height here, the one with the 30, is going to be 4 times the square root of 3. Anyway, I needed that because that's part of the formula. So I said, okay, half times 18 plus, and if this is 4, 18 plus 4 is 22. And then times my height, which is 4 square root of 3. Okay, well, 18 plus 22 is 40. Half of that is 20. And times 4 is going to be 80, square root of 3. But then I didn't get the answer in the back, so I'm like, okay, I must be doing something different. So then I said, okay, let me just find the area of this this rectangle, which is going to be 18 times 4 square root of 3. Remember, so I found that height. I was still going to need that height. So I did that, and then I'm going to add that to the area of this triangle. So first of all, 4 square root of 3 times 18 is going to be 72 square root of 3. The area of the triangle is 1/2 the base, which is going to be 4, times that height, which is 4 square root of 3. 72 square root of 3 plus 8 square root of 3, those are actually like terms. That's going to add to 80 square root of 3. Well, when you know it, I got the exact same answer that I get the first time, so I think the answer in the back for number 29 is wrong. Okay, number 30. What is the area of this kite? Remember, the area of a kite, kite and rhombus has the formula 1/2 diagonal 1 times diagonal 2. So all I got to do is add these diagonals up. 2 and 2 is 4. 6 and 12 is 18. So I'm just going to say 1/2 times 4 times 18. And that's just going to be 36. Okay, and that's going to be square feet. Okay, 31. Find the area of a hexagon with an apothem of 17.3 miles long and a side 20 miles long, round to the nearest tenth, which is one decimal place. Okay, blah, 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 blah. This is a regular hexagon. So inside, basically, you're going to have you can have like a whole bunch of little pieces in here. You're gonna have like 6 parallelograms. 6 little triangles in here. And my phone's about to die. Okay, so anyway, so let's go through this fast. So I need the area of one of these triangles. So I'm saying 1/2 times the base. Hold on, times the height. I didn't put this in, but the apothem is from the center to the midpoint right here, so that'd be like your height of one of these. So 17.3, and then times 20 is how much this is on the outside. So 20 times the height right there, 17.3. So if I do that, I'm gonna wind up with 173. Well, I have six of these inside, so 173 times 6, I'm gonna get 1035, and this will be square miles. 32. I'm being asked for the ratio for perimeter and the ratio for the areas. So I'm just saying one to the other. So I'm just saying 27 over 24. That's going to be 9 over 8, which is going to be the ratio for the perimeter, and you just square that for the area. And you would actually cube that for volume, which we're going to do in a second. Okay. Okay, so that was 1083 square miles. Oh, already did this one, the perimeter and area ratios. Okay, so page 5. So let's look at number 33. We need the lateral and the total surface area here. So we're looking at this here. Remember, lateral just means all the way around, not including bases. So this is a triangular prism, which means I have this flat, this rectangle on top, the rectangle on the back, and the rectangle that's on the bottom. So the rectangle on the top, I'm just saying 23 by 12.04. The one on the back is 8 by 23. And the one on the bottom is 9 times 23, or vice versa. And if I multiply all that out, I'm going to get 667.92 to the nearest whole number is going to be 668. And then if I want my surface area, my total surface area, I need to add this lateral area, which is going to be 668. Or even if you kept it here, 667.92. And then I want the area of the triangles. Well, the area of a triangle is 1/2 the base times the height. And I have 2 of these. I'm going to say 2 times 1/2 the base of 9 times the height of 8, which is going to end up being 72. So plus the 667.92. And that's just going to be 739.92. Which is going to round to 740.